All right, hey class. I'm going to go through quiz 3. Um, so let's see. First thing, name. Do I need to put my name on it? We'll just write key because this will be the correct solutions. So these first ones, I just want to kind of go through how someone might do these. Um, let's first take a look at kind of what the graphs and what the graphs mean. So if you notice, it's distance from home over time. So how do we interpret this? So what this means is consider this as time zero. And then it's not saying, specifically, is this an hour later or whatever, but it's some time later. And then the distance from home. So this graph means that you start at home because your distance is zero at time zero. And then it's a straight line. And so a straight line means constant speed. So I wrote straight line means constant change, but in this case, it's the change in distance, which is speed. It won't always be speed, it depends on the situation. But so we've got a straight line, and so in this situation, we are moving away from the home at a constant speed or rate. Constant rate, it says up here. Okay, so let's take a look at B. So what's going on in B? So in B, at time zero, we are away from our home, and then we are coming closer and closer to our home at a constant rate. What's C saying? Well, C is just a horizontal line. So that means our speed's not changing at all. In fact, our speed is zero. So our distance is constant. So however far this is, it doesn't say, but it's the only graph where we're just sitting there. Our distance isn't changing. Our speed is zero. Now let's take a look at D, what's going on. So we kind of come up like this. So what this means is that our distance from home is increasing. But what this means is we're starting off going slow, and then all of a sudden, we're taking off and our distance is going fast. So we start speeding off. So we start off slow, and then we're getting faster and faster because our distance is getting further and further at a faster rate. Likewise, if we look down on E, let me make sure I'm on the camera. What's going on E is we're leaving home really fast because our distance is growing really quickly, and then it starts to taper off. So this would kind of represent a situation where we're just like, I'm out of here, taking off, leaving real fast, so the distance goes up quick, and then we just start being like, oh, okay, now I'm just going to start cruising nice and slow. And in fact, we could say if this comes like this, then what would be happening here is that our car actually stopped, right? But we're still this far from home, this distance from home, but we've just stopped and maybe parked. So likewise on G, let's take a look at what happens here. So here we're away from home, and our distance starts dropping fast at first. So that means we're driving really fast. Our rate is fast getting home, and then it starts to taper out. So what that means is that we start to just kind of coast, and we're like, and then we're kind of like, well, I guess I'll pull up into the driveway eventually when we hit zero. Okay, so now taking a look at our options up here, a car is parked 5 miles away from the house for the entire day. So the only one that could represent that is the key here is it's parked, it's not moving. And the only one that represents not moving, because our distance isn't changing at all, our distance is always this distance here, is C. So the only choice there is C. Well, let's take a look at the second one. A car is on its way home and drove slower as it got home. So again, the only ones that represent on its way home would be B or G. Now B, we start off away from home, and we do head home, but at a constant rate because it's a straight line. It means our speed is the same at the whole time. We're just getting closer and closer at a constant rate. However, on G, we drove slower and slower as we get home. So we're getting slower and slower. So maybe there's something at home we're just like we don't want to deal with. So we're like driving home and we're like, oh man, I don't want to go home because of whatever. And so you're just like, okay. And then finally, you're just like, all right, I guess I'm home. So that would be G. Okay, and then 3 again has constant rate. So a car returns home safely. So the only one that represents that is B because we start off, we're not at home, we're this distance from home, and boom, and this represents our distance goes to 0, so we get home. So that one is B. And then a car leaves home traveling at a constant rate is the only options are A and E because they're the only ones where we start from home. Oh, no, D could be also. D, we start at home because we start where our distance is 0 on these 3. But the only one that's a constant rate is A. Okay, let's take a look at the other side. It says, well, I don't want to read through the whole thing, but basically what's important here is that here's our equation, and so this one's a little different than others because some of the others is we were given the situation, we had to come up with the equation. Here we're given the equation, but we got to make sure we understand what is the x and what is the y. So the x is our input, and that's the number of hours the snowboard's rented. And so y is the cost of the snowboard rental is given by. So that's our y value. So first we want to explain what the point means in the situation described above. So what this means is, so this is the input, which is 0. So that means we're renting it for 0 hours, and the output is $9.50. Okay, so in this situation, it almost doesn't make sense because can you really rent it for 0 hours? But in a sense, it's like the initial cost. The amount it would cost to rent the snowboard for 0 hours is $9.50. So I also, some people put down the answer of like, the initial cost, that type of thing. Anything like that is fine. So now let's take a look at part B. You paid $41.50 when you returned the snowboard. How many hours did you rent it for? Okay, so all we need to do is we've got our equation up here, and we paid this amount. So remember, y is the amount we paid. So let's put that in for y. $41.50 equals 4. And it's saying how many hours, and the number of hours is x, so that's what we want to find, plus $9.50. Okay, so now we need to go solve this. And so to do that, let's subtract $9.50 from both sides. Remember, we want to get the x by itself, and that'll tell us how many hours. And so we do this. We got $41.50 minus $9.50. That's 32. So 32 equals 4x. $9.50 minus $9.50, that's gone. So 32 equals 4x. So now we want to get the x by itself. So we divide both sides by 4. And 32 divided by 4 is 8. So x equals 8. So 8 hours. Okay, so finally, let's represent this function graphically. Make sure to label the axes carefully. So I'm the type of person, I like to just start down at the bottom at 0, 0. And so then what you want to do is kind of figure out how to scale this. So if we look back up here, a snowboard rental company opens every day 6 a.m., closes 6 p.m., so that's a total of 12 hours. So really, the most hours we could rent it for is 12. So we want to make sure we can at least fit around 12 on the bottom. So maybe let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We didn't quite fit it in. That's okay. Now then going up is going to be the cost. So down here it's hours or time. Oh, that's not on the screen. Sorry about that. So time in hours. And then this is going to be the cost in dollars. Now let's see, how do we want to scale that one? Well, we know when it's 8 hours, it's going to be $41.50. So, I don't know, we want to maybe make it so that about $50 can fit in here or so. And again, we can always fix it if we don't like it. Let's just maybe go, let's see, 10, 20, 30, 40. Yeah, that'll be good enough. We'll go by 2, so we'll say, so this is 10, and then so we'll go 2, 4, 6, 8, 10, 20, 30, 40, okay, something like that. So now we know if we run it for 0 hours, so how do we find these points? Well, we can make a little table here. We can go X and Y, and we can just start putting in some values. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. So we just plug it into the equation. So this would be 4 times 0 plus 950. We already know that's just going to be 950. So at 0, it's 950. So that's about right around here on our graph. Okay, so 1 hour would be 4 times 1 plus 950. And that comes out to be 1350. So at 1 hour, our output will be up here at, let's see, so here's 15. Somewhere around here. Okay, now the one key here is we've been studying linear equations, and so when we have things in this form, we know it's a straight line. So really, once we get 2 points, we can just connect the line, and that'll give us all our points. So we already know a point up here. We know we could figure out the rest of this. This would be 4 times 2 plus 950. And plot those. So 4 times 2 is 8, plus 950 would be 1750. So at 2 hours, it'd be somewhere around 1750 is somewhere around here. But we know that when we plug in 8, we get 4150. So we can plug in that point too. 8, and our output is 4150, which would be right around. Make sure I'm on the screen. So we go over 8, up 4150. And so you can see all these points are going to end up being in a line. And so we can then just connect this line. So I'll get something to make a straight edge and go like that. And so now what this does is our graph can tell us, we don't have to plug in all the points. We know that, like, for example, if our time is 6 hours, we just go up and we see that our output is around 32, 33, something like that. Of course, we could get the exact answer over here by going 4 times 6 hours plus 950. And so what's that equal? That's 24. That'll be 33.50. Nice, and that's about what we said. $6, you go up, the output is right here, which if you go over is right around where 33.50 would be. Okay, hopefully this helped. Feel free to ask me questions on this. Come on into office hours and party on.